All right, folks, so what we're going to do today is we're going to learn what a radian is. We're going to develop formulas to convert between radians and degrees. We're going to do some conversion problems, and we're going to develop a formula for arc length. All right, so what exactly is a radian? All right, so here, as you can see from our definition, a radian is an angle measure whose angle captures an arc of a circle that is exactly one radius in measure. So imagine you had a circle with some type of radius, right? And let's just say this is a radius of 1 meter. So if I were to, let's say, take a piece of string that was equal to one radii, I could put that piece of string along the edge of the circle, right? And then at the end of this piece of string, I would have my radian. So there's 1 radian, and this arc length right here is 1 meter. So that's essentially what a radian is. It's basically another way to measure an angle. It's another, I guess, unit of measurement. Right. So now we'll talk about, the degree measure of 1 radian. So again, just like before, we're going to assume that 1 radian, or excuse me, the radius of our circle is going to be 1 unit. So we want to see, well, how many radii covers the circle? So here we could just take a look at this already drawn out example. So we have 1, we have 2, we have 3, we have 4, 5, 6, and then we have this portion left over right here. And without getting into too much detail, this portion is basically 0.28, right? And if you remember from the circumference formula of a circle, 2 pi r, so you can find the circumference just by knowing the radius of the circle. So here we said that the radius was going to be 1, so if I substitute 1 in for my radius, I get 6.28. So basically I could take 6.28 radii and just cover it along the circumference of the circle. So we have 360 degrees of a circle, and we know we have roughly 2 pi, well not roughly, but exactly 2 pi radians. So here, if we take our degrees of a circle and we take the number of radians it takes to cover the entire circumference of this circle, we divide 360 divided by 2 pi, or 2 pi times 1, which is our radius, we get roughly 57.3 degrees. So 1 radian is going to be roughly equal to 57.3 degrees. Right, so it doesn't really matter the size of the circle. It doesn't matter if the radius is 1 or 10 or 50 or 1/2. 1 radian is going to equal 57.3 degrees regardless of the size of the circle. All right, so now our objective is to look for formulas for conversion, because in this class you're going to be expected to convert between radians and degrees. So if you remember the unit circle, we had a couple of measurements. We had degree measurements, and then we had these radian measurements. And our goal is to be able to go from pi over 3 radians to 60 degrees, or go from 30 degrees to pi over 6 radians. So let's take a look at what we learned from before. Again, we know that basically 2 pi radii, or 2 pi radians, is going to equal 360 degrees. So what we're going to do is we're going to divide both sides by 2 pi, right? Because we're trying to solve for 1 radian. So our formula right now, we're looking for a formula for 1 radian. So I'm going to divide both sides by 2 pi. And then when I simplify to 360 divided by 2, I get 180. So I could also write it out like this, which is typically how it's written out. So 1 radian is going to equal 180 over pi. So we're not going to use the estimated form of radians. We're going to use the exact form. So we're going to leave our answer in terms of pi. So 1 radian is 180 divided by pi degrees. And if you take 180 divided by pi on your calculator, you're going to get roughly 57.3 degrees. All right. Now, let's say we wanted to have a formula for degrees, or in this case, 1 degree. So we take the formula that we just got right here. 1 radian equals 180 divided by pi. So what we're going to do is we're going to take that formula and simply multiply it by the reciprocal of 180 over pi. So if I divide by or multiply by the reciprocal, I get pi over 180 on both sides. And actually, let me rewrite this so it's a little bit more clear to see. So I take the 180 over pi, which is what I had up here, and then I multiply by pi over 180. Right, and keep in mind the units here were degrees. Right, so technically this is degrees, but I'm going to save the units till the end. So the 180s, they cancel each other out. The pi's, they cancel each other out. That's why we end up with 1 here. And then the pi over 180, we can't really do anything about that, so we just leave it as is. So here, pi over 180 radians equals 1 degree. So we have our formula for 1 degree, and we have our formula for 1 radian. And we're going to use these formulas to convert between degrees and radians. Right, so let's take a look at some examples. So I'm putting up the formulas from the previous slide right here. So we have 15 degrees and 195 degrees, and I want to convert them to radians. And then we have pi over 5 and 9 pi over 5 radians, and I want to convert them to degrees. So how exactly do we do that? So let's take a look at the degrees first. So here I'm going to take 15, and I want to convert 15 degrees to radians. So if I take a look at my formula right here, I look for the 1 degree formula. So 1 degree equals pi over 180 radian. So I'm going to take this formula right here, and basically I'm going to distribute this 15 towards this formula. Right, and I'll worry about the units later on. So here I have 15 degrees equals 15 over 180 pi radians. And here I want to make sure that I can simplify. So if I simplify 15 over 180, I get 15 degrees equals pi over 12 radian. Because 15 over 180 simplifies to 1/12. So that's my answer. So let's try 195. So again, I'm going to repeat the process. I want to convert 195 degrees to radians. So here, I'm going to use this formula, my 1 degree formula, right? Because I know 1 degree equals pi over 180 radians. So if I know 1 degree equals this, all I would have to do is just multiply by 195 on both sides to get my measurement in radians. So once I distribute the 195, so I get 195 degrees, and that's going to equal 195 pi over 180, right? And then, so what I have is 13 over 12 times pi radians. Right, so that's how I get my degrees to radians. So now let's do the opposite. So I want to take my radians and then convert them to degrees. And you could pause it right now and see if you can figure this out on your own. So I take my pi over 5. And then, because I'm interested in going from radians to degrees, so I take my 1 radian equals 180 over pi degrees formula, and I'm just going to repeat that process. I'm going to distribute this pi over 5. And actually, you know what? Okay, I can't actually, let me erase this. All right. So let me hold off on the units because I think that might make things a little bit cleaner. So I'm going to distribute this pi over 5 to my formula, so I get pi over 5 equals 180 times pi all over 5 times pi. All right, and you're going to notice that the pi's, they cancel each other out, and then 180 divided by 5 is going to equal 36. All right, so here pi over 5 radian equals 36 degrees. All right, now you can, again, pause this video, try 9 pi over 5 and convert that. So I'm going to take 9 pi over 5 and repeat the process. So again, I'm using the same formula. Right. Now, I typically leave the units out for the most part, just because it gives me a little bit more room to work, and then I make sure to add the units at the end. So again, I'm going to distribute my 9 pi over 5. So I get 9 pi over 5 equals 9 pi times 180 all over pi times 5. So here the pi's are going to cancel each other out, and then I could take 9 times 180 divided by 5, and I get 324 degrees. Right. So here I have 9 pi over 5 radians equals 324 degrees. Right. So you can let your calculator simplify your fractions. I'm not able to show my calculator on the screen here because I'm recording with PowerPoint, but if you go to Math on your TI-83 or TI-84 and then you go to Fraction, this option on your TI-83 or TI-84 will automatically simplify the fractions for you, right? Which is obviously very nice. All right, so now what we're going to do is we're going to try to find the arc measure formula. All right, so here, let's start first with a problem that you've seen before. We're going to find the radian measure of the major arc from B to C, and I apologize, the C got cut off. I don't know how that happened. So if I take the major arc, all right, and obviously my curve is not very good, so I want to find this major arc, this radian measure of the major arc, because as you've seen before, you could find the degree measure of an arc. So now we want to basically take the radian measure of an arc. So I know this is 40 degrees, and my central angle measure is going to equal the intercepted arc measure. So I know this is 40 degrees. And if I take 360 minus 40, I get 320 degrees. All right, so that's the measure of this major arc from B to C. And then if I take 320 degrees and I multiply it by my 1 degree formula, because I'm trying to go from degrees to radians, so that's why I'm selecting this formula right here. I repeat the process just like I did from the previous slide. All right, so I distribute the 320 to the entire formula. So I get 320 on the left, and then 320 pi over 180 on the right. And if I simplify 320 over 180, I get 16 over 9. And realistically, when you're simplifying, just ignore the pi. All right, add pi at the end. So again, knowing that the pi is in the numerator, I'm just going to ignore it when I simplify 320 divided by 180. I get 16 over 9, and then I put the pi back at the end. So the measure of this arc right here is going to be 16, or at least the degree measure, that is, 16 pi over 9 radians. All right. So let's try the next problem. All right, so now what we want to do is we want to find the arc length. All right, so find the arc length of the major arc BC using your radian measure. So here we know that 16 pi over 9 is the length of the arc measured in radii. So this was the previous problem. So 16 pi over 9. So this is the degree measure. All right. What I actually want to find is the actual measurement. So if you were to kind of take a piece of string along this major arc from B to C, you know, how long would that piece of string be essentially? So here I know my radius is 3 meters. All right. So I'm going to keep that in mind. Right. So again, 16 pi over 9 radians, that's the degree measure of our major arc. And we know from before, a couple of slides ago, that this basically tells us how many radii are covered along this major arc. So 16 pi over 9 radii is the distance from B along the major route to point C. So here, my radius is going to be 3 meters. So all I would have to do is take my radian measure and multiply by my radius measure to get the total arc length. So in this case, again, this is my angle, and this is basically, the 3 is going to be my radius. And then if I multiply that out, 3 times 16 pi divided by 9, that simplifies to 16 pi over 3. So 16 pi over 3 meters. So this is the actual measurement. So if I were to take 16 pi on my calculator, divided by 3, it would be roughly 16.7552 meters, because my units are in meters. So you'll notice that this is a lot quicker than, you know, using the degrees and trying to find the arc length. So we basically just develop our formula for finding the arc measure just as long as our angle is measured in radians. So here our formula is arc length equals the radius times the degree measure of the arc. And again, I want to emphasize that the angle measure has to be in radians. All right, that's why I underlined this. It has to be in radians. Otherwise, it's not going to work. So let's see an example of this real quickly. All right, so I want to find the major, or excuse me, not the major, the minor arc length of BC. So from B to C, I want to find that minor arc length. So here, let's say I'm given the angle measure in radians, 3 pi over 5, and I just want to find the actual physical measurement of this minor arc right here. So all I have to do is just plug in this formula. So S is typically the letter used for arc length. Why, I don't know, but regardless, you'll see this pretty often and pretty frequently in formula sheets. So here, my arc length is going to be my radius times the angle measurement in radians. So that's 3 pi over 5 for my angle. And if I just cross this out, and that's going to be, whoops, that's going to be 3 pi meters. And 3 pi is roughly 9.4248 meters. And that's it.